All right, we're going to start off with percent yield here and how to calculate it. So percent yield, essentially what you're doing is you're comparing what you got when you did an experiment, so how much product you got out of a reaction, and you're comparing it to how much you should have gotten, which you know that number after doing one of your stoichiometry calculations there. Okay, so theoretical or predicted yield, that's just how much you're predicting you should get by just doing a calculation. Your experimental yield, that's what you actually get out of a reaction when you conduct an experiment. Okay, so reactions, they don't go to completion like we have been assuming they do. There are factors that can limit just how much product you get out of a reaction there. So one of the factors that could limit how much product you get is collection and transfer method. So essentially this means every time you transfer chemicals from one container to another, you're going to lose small amounts of it. Okay. When you rinse precipitate with water, sometimes that can dissolve your precipitate out of your final product, or some final product remains dissolved in the filtrate and it's going to go through the filter paper. You're not going to be able to collect it, so you lose some product that way. Okay. Another thing that's going to affect your experimental yield is just how pure your reactants are. Most chemicals aren't 100% pure. And like I said, the last one here, reactions in reality don't proceed to completion. So that means they don't produce 100% products. Okay, and that's just because reactions reach something called their equilibrium point and they just kind of stop reacting. Okay, and it looks like everything has reacted, but it hasn't. And typically we don't worry about these types of reactions until Chem 30 in the equilibrium unit. All right, now how do we calculate percent yield? Okay, so percent yield, that's going to be equal to the experimental value divided by your theoretical value. And because it's a percent, we got to times it by 100. Okay, so experimental, that is the mass of the product that you actually got in the lab. Okay, whereas the theoretical value, you don't do an experiment for that. You just do a calculation for it. Okay, so this is calculated. And it represents how much you should have gotten if your reaction went to 100% completion. So if your reaction produced 100% products. Okay, so you could kind of think about percent yield sort of like the percentage that you get on a test. Okay, so let's say you got 48 questions correct out of 59 possible questions on an exam. Okay, so if you calculate your percent yield or your mark, okay, how you would do that is you'd go percent yield is equal to 48, so what you actually got, okay, divided by, if everything was perfect, what you should have gotten, which is 59. Okay, so 48 divided by 59 times by 100. Let's see, 48 divided by 59 times by 100. That's going to give us 81.3559, goes on forever, percent. Okay, Now, since the numbers that were given, they only have 2 sig digs, we need to put this into 2 significant digits, which is just going to be 81%. All right, let's move on to the next example. So now this is a little bit more, we're involving chemistry a bit more using an experiment. So we got a student performs a chemical reaction that produces silver chromate, and using stoichiometric calculations, she expected to attain a mass of 1.40 grams. So she's doing a calculation, and her calculation said she should have gotten 1.4 grams. Okay, so this right here is a theoretical value because she calculated it. So the key with these types of questions is being able to tell what's your experimental value and what is your theoretical value. When she weighed her product, so weighing her product, she would only do that if she was in a lab doing an experiment. It had a mass of 0.90 grams. What is the percent yield of this student's reaction? Okay, so this is experimental. So percent yield is equal to experimental divided by theoretical, which I'm not going to write all of that. We'll just go theo, times by 100%. Okay, so if we plug in our numbers, experimental, that was 0.9. Divided by what we should have got, or the calculated value, 1.40. Times by 100%. So our percent yield, if we do that, 0.9 divided by 1.4 times by 100, we got 64.2857. Goes on forever. But since we have 2 sig digs coming from this number, so how I'm counting sig digs here, leading zeros don't count, but non-zero digits do count, and trailing zeros count, so this is 2 sig digs. Okay, so we need 2 sig digs, so 1, 2, there's our cutoff line right on the decimal point. So 64%. All right. Now, something a little bit different from percent yield. This is going to be percent error, or sometimes it's called percent difference. Okay, so percent error is used to determine how far away a value obtained in the lab is from a theoretically determined value. Okay, so before percent yield is like, okay, how much product did you get compared to how much you're supposed to get? And then percent error is just analyzing, okay, how far away is your value from the value you were supposed to get? Okay, so typically an acceptable percent difference or percent error is within 5%. Okay, so the formula for percent error or percent difference, that's going to be an absolute value sign, and it's going to be experimental minus theoretical divided by theoretical, and we're going to close the absolute value sign and then times it by 100%. Okay, so if you're looking at these absolute value signs and you're wondering what on earth do they do, for chemistry 20 purposes, all you need to know is that your answer is always going to be positive. That's what they do. Okay, if you go into math 20-1, they'll get into the nitty-gritty of that and how that happens. So for the first example, we're asked to calculate the percent difference or percent error, same thing, if 37.5 grams was a mass determined in an experiment and 47.1 grams was the theoretical value. Okay, so this one's pretty straightforward here, but once again, the goal for these, or the trick to these types of questions, is can you determine which number is your theoretical value and which number is your experimental value? Okay, so since 37.5 grams was determined in an experiment, that means this is the experimental value. Okay, and 47.1 was the theoretical value. Okay, so percent error is equal to, so experimental value comes first, so 37.5 grams minus the theoretical value, 47.1 grams, divided by the theoretical value, 47.1, absolute value signs, times by 100%. Okay, so if I do this here, we're going to go 37.5 minus 47.1, hit enter. Okay, now we got a negative number, but that's fine. The absolute value signs will take care of it eventually. 47 divided by 47.1 equal, okay, so I'm going to apply the absolute value signs, and this negative number will turn into a positive number. If you already have a positive number within the absolute value signs, it remains positive. Okay, so I'm going to go 0.20382, keeps on going on forever, times by 100%. I'm going to have to scooch this up a little. So percent error, so 0.20382 times by 100, that's going to give us 20.382, keeps on going on, percent. All right, so it looks like both numbers that we were given here have 3 sigdigs, so I'm going to report this in 3 sigdigs. So 1, 2, 3, there's my cutoff line. So 3 sigdigs, 20.4%. Okay, so in our next example, we have a double replacement reaction that took place in a lab, and the following evidence was recorded. The filter paper collected the precipitate produced during this reaction. Calculate the percent yield from the experiment. Okay, one adjustment we need to make here is this question should have what exactly that double replacement reaction was, so we are going to write that in. Okay, so the reaction that took place was barium nitrate solution reacted with sodium chloride solution, and it produced barium chloride and sodium nitrate. Okay, so it's just a double replacement reaction happening. Okay, so barium chloride, if you look that up in your solubility table, that's going to be a solid. Sodium nitrate, that's going to be soluble in water. Okay, now if we balance this equation, well, we got 2 nitrates going in, we want 2 nitrates coming out. That means we got 2 sodiums coming in, or coming out, we want 2 going in. So sodiums are balanced, and for chloride we got 2 going in and 2 coming out, so everything is balanced, because for barium, 1 going in, 1 coming out, everything's good. Okay, so this is the reaction that happened, and we've collected some data here from that reaction happening in a lab. Okay, so the mass of barium chloride That's the mass of our precipitate. How we know it's our precipitate is because we mixed two solutions, two aqueous solutions together, and we got a solid product out of it. And the solid product is referred to as the precipitate. Okay, so let's label that precipitate. Okay. All right. So essentially what they're trying to say here is mass of barium chloride. So the theoretical mass of barium chloride, which is our precipitate, is 4.55. So the theoretical mass of barium chloride is 4.50 grams. And here we have the mass of the filter paper and precipitate. So this is stuff gathered from doing the lab. So this is gathered from the lab. Because you're only going to deal with filter paper in the lab. So they've given us filter paper and precipitate is 4.37 grams. The mass of the filter paper alone is just 0.12 grams. So essentially, I'm going to just do a little drawing to explain the math here. So we got our filter paper and precipitate. We've got our filter paper. And in order to figure out percent yield, if we've already been given the theoretical amount of our precipitate, barium chloride, we're going to want the experimental amount of barium chloride. So we're going to want just the precipitate part. So mathematically, what we need to do to these two numbers is we need to subtract them. Okay, so if I take 4.37 grams and subtract 0.12 grams, 4.25 grams. Okay, so this right here, that is the experimental value because the two numbers that we used to get it were gathered from the lab. Mass of precipitate. Which in this case is barium chloride. Okay, I'm just putting this in brackets just to be like I'm specifying here. Okay, so let's figure out percent yield from this. So remember, percent yield is your experimental value divided by your theoretical value times by 100%. Okay, so our experimental value, that was the 4.25. And the theoretical value, that was this 4.50. So right now it's looking like they got a pretty high percent yield. 4.25 divided by 4.5. And then times by 100 would be 94%. Okay, or 94.44. Kept on going on forever. Percent. Now looking at the numbers given in our question, looks like we need to have our final answer in 3 significant digits. So if I start counting from the far left-hand side, 1, 2, 3, there's my cutoff line. So my final answer is 94.4%. All right, now what I also want to do with this question here is I want to also just practice percent error. So I'm going to do that over here. So just as a reminder, percent error is equal to absolute value experimental minus theoretical divided by theoretical, close the absolute value sign, times by 100%. Okay, so our experimental value, that was 4.25, minus our theoretical value, which was 4.50, divided by 4.50, absolute value signs, times by 100%. So if I put that into my calculator here, so 4.25 minus 4.5 divided by 4.5. Okay, and remember that absolute value signs will take whatever answer you get and make sure that it's positive. So since we got negative 0.055 repeating, the absolute value signs turns this into a positive. So just to take that into account, I'm going to times it by a -1, just so that we have a positive number to work with, and then times it by 100%. So this is going to be 5.55 repeating for percent error. And actually, I'm going to go ... percent. So this line over top of the 5s just mean they keep on repeating. All right, so like we said, the numbers given to us are all in 3 sig digs. So I'm going to put my final answer here in 3 sig digs. So counting from the left, 1, 2, 3. There's my cutoff line. So it's going to be 5.56%.